In this video, I'm just going to go over passive sign convention and then do an example problem. So passive sign convention is relevant for power. So let's say we have a circuit element, positive terminal with a voltage of V, negative terminal over here. And then let's say there's a current I going through the element through its positive terminal. Passive sign convention tells us that power P equals positive I times V. Now, let's say we have the same circuit element plus V minus, except this time the current was going through the negative terminal. Our convention says that P equals negative I times V. Now, what this is saying, we call positive, we say power is being absorbed by this element. And then for when the current goes through the negative terminal, we say power is being supplied. So that's pretty much it. If current goes through the positive terminal, then power is absorbed by that element. And if current goes through the negative terminal, then it's being supplied. And if it goes through positive, it's just I times V. If it goes through negative, it's negative IV. So now let's do an example. So let's calculate the power absorbed or supplied by each element. So now we can just start at the first one. So P1 equals, let's see, here is element 1, and it has 45 amps going through it, and it's passing through the negative terminal. So that means P1 equals negative 45 times 5. Okay? And that is equal to negative 225. Okay. Watts. Equals, let's see, the 45 amps is going through the positive terminal and it's 2 volts. So it's just 45 times 2. So that equals watts. Now, $20 amps is going through the positive terminal. So we say P equals IV. 20 times the voltage here. Now this is a current dependent voltage source. So P3 equals 20 times 0.12 times I. But we can see up here I equals 25. So this is 20 times 0.12 times 25, which equals 60 watts. And then finally, P4, the current's going through the positive terminal again, and this time it's I, which is 25, so 25 times 3 equals 75 watts. Okay, now we can check if we got these right by just using conservation of energy. So for a circuit, conservation of energy is that the sum of all the powers in a circuit equals 0. And we can see we've got this negative 225. So earlier we said If it's negative, that element is supplying power, and if it's positive, that element is absorbing power. So logically, we can say that the power being supplied by P1 should be equal to the negative of all the absorbed powers. So if we follow our rule, sum of powers equals 0, we just say negative 225 plus 90 plus 60 plus 75 has to equal 0. And if you do 90 plus 60 is 150 plus 75, you get negative 225 plus 225 equals 0. And that checks out. So that means seems correct.